make adjustment if the sample mean, if the mean, okay, I shouldn't say the sample mean, okay? If the mean sorry, if the mean weight of bags of sugar is above 1001 gram or below 999 grams. So you do see that 1 gram, if one day you produce 100,000 bags, that is become a lot, correct? So it cannot be too much, cannot give to the customer too much. The company will be running at the loss. If you give not enough, the customer will complain. So now, what should the how to know whether to adjust or not adjusting? So how can he make the decision whether to adjust or not to adjust? Okay, how is he supposed to make a decision? Take one bag, or take many bags, or take all and weigh? If you one day you produce 10,000, so how? So now our question is how to make decision. How can he decide? How can he make decision? How can he make this decision? Whether to adjust or not to adjust. So anyone, any suggestion? Based on what we have learned so far? Do you think he will weigh everything? Someone has tell me already. So first, all right. Okay, by taking a sample and count the mean, right, of that sample. All right. So now if you want to take a sample, so our issue will come. What issue will come? What should the sample size be? You tell me, what should the sample size be? Can someone suggest to me a sample size for this case?
50.
Okay, someone say 30. Why 30? Okay, someone say 30. Okay, someone say sample size 30. So when you say by taking a sample and count the mean of that sample, okay, fair. So now your issue is you have to know the sample size. You have to settle the sample size problem. So what is the sample size supposed to be? Why 30? I ask you in this case, why 30? If I take 10 can or not? If I take 8 can or not? Hello, you have to give me the answer. If I take 10 can or not? Okay, someone say bigger number, more general. So every time when we talk about sampling, whether it's a suitable sample size or not, we have to get back to our very powerful rule. What is that powerful rule?
CLT.
Yeah, CLT, good. So we have to say according to CLT. Okay, according to CLT, I'm talking about this situation according to CLT. So what is the suitable sample size? What is the suitable sample size?
At least 30.
At least 30. Why at least 30?
That way it becomes, the sample mean distribution becomes normally distributed.
Okay, so what is, according to central limit theorem, the first part is you must have a suitable sample size so that the sample mean is normally distributed. Am I right?
Mhm.
That's what you want. But in this case, should I take sample size of 30? If I take 8, can or not?
Yeah, it will still be normally distributed.
So that's why. So determine the sample size is all very much depend on the
Population size.
population here. You see or not? According to CLT, according to CLT, if the population is normally distributed, the sample mean distribution is normally distributed regardless of the sample size. Whatever sample size also doesn't matter. So you see, so that is how when you talk about your folio, all right? So you have an issue here. This is your issue. You want to you want to make a decision whether to adjust the machine or not to. Okay, so now what is the population? So can anyone tell me what is the population that I'm going to draw the sample from?
Like the
So-
population size.
What is the population? Can you define the population?
The number of packs of sugar in 1
Is
kg
that-
bag.
Is that?
Oh wait, the number of packs of sugar, the number of bags filled with sugar by the machine. Wait, how to
By
phrase
the
this?
machine.
Yeah, by the
All
machine.
all the 1 kilogram bags of sugar that is packed by this machine. So that is the population. So what is the parameter that I want to talk about? What is the parameter that I want to study?
The weight of the.
Is it the weight? Is it the weight?
The mean weight of the bag.
Yes. So this is the parameter. So when you write your folio, you give a scenario already that you want to study, that you want to talk about. So what you do, you define the parameter, you define the population clearly. Then when you write, you can say like what Ms. Do did here. How can he make the decision whether when to adjust the machine and when not to adjust the machine? So then you start by taking, you have to take the a sample. So when you take a sample, and you have to find the sample mean. So when you want to take a sample, you have to determine the sample size. So there you can bring in central limit theorem. So depend on your population. If your population is normally distributed, then your sample mean distribution will be normally distributed regardless of the sample size. Okay, are you okay? Can or not? So I'm trying to give you the flow. How are you going to flow your content? I'm using this example. So when you write, you have to plan. Then after that, you have to consolidate all your things. Okay. So, got it? Okay, so now if I give you a sample, okay, now I give you a sample. Actually, this is taken from your book. So I have a sample, the person collect a sample. Okay, randomly, as the thing is produced, he may collect one in the morning, then another one at 11 o'clock, another one at 12 o'clock, and so on and so forth. So it don't just take one whole batch. So that is called random. Okay, so now maybe one take for in a particular day, take the bags at different times. So he record down the weight. Okay, he record down the weight and you got 1001 gram, 998 gram, 999 gram, then another one 1001 gram, another one 1003 gram, then another one 1002 gram, then another one 1001 where I leave out 101 998 990 101 103 102 101 gram. 1 2 3 4 5 6 7. Also altogether got 7. Okay, so now, so based on this sample, we count sample mean. So you have to define what is X? What is X? So you define what is X? Weight of a bag of sugar. Okay, so can you take out your calculator and find the, okay, what is the sample size here?
7.
7. Okay, take out your calculator and count the sample mean. So if you are writing your report, you write down the formula. Then you write down the number, then you give the answer. So I'm doing so everyone have to do exam. Can I give question like that? I can. Okay, so I got 7005 over 7, right? So you get 1000.71 gram. Is it correct?
Yep.
Okay, good. So now, can I go to the next page?
Sure.
Okay, I go to the next page. Okay, so now, according to central limit theorem, the sample mean distribution is normally distributed, correct?
Yep.
So this is my sample mean distribution. So it's normally distributed. Okay. Do I know my mean of the sample mean distribution? Do I know? Do I know it? Do I know my the mean of the sample mean distribution? I don't know. Am I right? I don't know. Because according to CLT, the mean of the sample mean distribution, this is sample mean of the sample means distribution. Okay, is equal to the population mean, correct? Am I right? So I want to use, so I take a sample. So my sample mean may be here. Okay, my 1,0,0.7 what? Just now 7,7,1. So 7,1 is here. My population mean is here. Correct? So what is the chances that, what is the chances that my sample mean is equal to 1,0,0,10.71? You tell me what is the chances? What is the chances? The probability is equal to 0, correct? Am I right? Why is it 0? Because this is a continuous variable. Okay? Hello? So that means, can I say, okay, can I based on this say, oh, no need to adjust? I cannot, because just based on one sample, the chances of my population mean to be equal to this is 0. So we take this, one of the sample mean that is 1,000.71 gram as as a point estimator. Oh, I can say it will be cluttered around there as a point estimator. Okay, so the sample mean that the one sample that you get and the sample mean can only be a point estimator. For the population mean, the chances of the mean weight to be that particular value is 0. It's very unlikely. Okay, so we call this a point estimator. So remember, your particular sample mean is as a point estimator. So we are going to use, so every time when we talk about, we are going to estimate as a range. So we are going to predict or estimate the true population mean weight of a bag of sugar or I can say of bags of sugar as a range of number. Okay, and this range of number is based on a confidence level. Okay, I will explain this to you. Don't get the one, confidence level. Okay, I will explain the confidence level to you. So on a confidence level example, I take 95%. So I'm going to explain one by one. Okay, so that means this is my point estimator. So I'm going to use this as a 95 confidence level. So I'm going to try to make a range. So I'm going to try, okay, use this, I will try. So this is my lower, this is my upper. So you see it captured the population mean. So if I take another sample, okay, I may estimate another range, then I will get another, maybe my mean is here, my sample mean is here. So I capture. So it will capture the population mean also. So I can have many of them. So the 95% confidence level means, 95% confidence level means, after I will write down, 95% confidence level means if I'm sure that 95% of the samples that I take, of all the samples that I take, 95% of them will capture the population mean. That is the meaning of confidence level. It is not the probability. It is the assurance that you have. Okay? So you are 95% confidence means you are confident that 95% of any samples that you take, 95% of them will capture the true population mean. In this case, is the weight. Okay, after I will write in words for you. So, are you okay? So how to get this, how to count this using your GC? I will give you the formula later. I try not to give you the formula now. Okay, so I'm going to go through that. So I'm going to tell you what do you mean by, okay, can anyone tell me what is 95% confidence level means? Okay, I'm going to write. I write confidence level means CL. 95% confidence level means I can have 99, I can have 90 and so on. Afterward, I will teach you the formula. Okay, I won't introduce the formula first. Means 95% of these many confidence interval for true mean, I write specifically mean weight of bags produced by the machine will capture the true mean weight of that. Produced by the machine. So that is the meaning of 95% confidence level. So we only have 5% that we are not sure of. And only 5% of the interval of the confidence interval that will not capture. True. Population mean. So everyone, are you clear? So if for example, I take 100 samples, okay, of the same size, and each sample, I count the mean, I find the confidence interval, 95 of them, I'm sure it will capture the true population mean. Only 5% will not. Only 5 of them will not. That is the meaning. It's not probability. It's not anything. Okay. So because in your folio, you also have to. So now, how are we going to count this true confidence interval based on the point estimator? Okay. Just now, what is our sample mean? Can someone give me?
1000.71.
Yeah. 1000.71. Okay, 1000.71 gram. Okay, 1000.71 gram. I cannot pronounce as 71 because it's not at the unit of 10. Okay, so now you take out your GC, everyone. You take out your GC. So this is our point estimator. And we know that it's impossible. Okay, so now, okay, take out your GC already. Okay, everyone go to stack. Okay, press stack. Go to test. Scroll down. Number 7. Do you see that? Z interval. You see that? Okay, select that. Okay, what you are supposed to put in? Input. You are supposed to select stack. Okay, input data. So you are supposed to select this one. Okay, then standard deviation 1.5. Just now we get from the population. Sample mean is 1000.71. And sample size. What is our sample size? Can someone tell me? 7. Confidence level 0.95. Okay, then you go to calculate. Okay, okay, then the answer will come out. Then the answer will come out. Okay, may I know what is the answer? Can someone tell me?
0.0817.
0.0817. Only one number, meh? Is it only one number or more than one number?
I don't know why, but it says binom CDF.
Why binom CDF? Oh? Cannot be binom CDF. Hello? You calculate, you enter. That's it. You don't enter another time. After you press calculate already, you just leave it. Then you will see things like that come out in the bracket. Do you see something like that come out in the bracket?
Yeah, we got
Yes,
999.6
Then
negative
comma 100
1.8.
1.8. Okay, so now I'm going to, so that means, so now I'm going to explain what does that mean. So look, allow me to explain first. This is a very hard topic to explain, okay? Because there are too many percentage and number here already. So I assume the middle is this one. Okay, so I'm going to assume, so this is the assumption. You assume that the middle of this normally distribution, normal distribution, the middle is your point estimator. Are you clear? So now you are 95% confidence that it is here. So this is your 999.6 and this is your 1001.8. So are you clear? So that is the meaning of confidence interval. You assume. So your point estimator is help you to make an assumption. You assume your point estimator is the middle of the normal distribution. So this is the assumption that you make. So you make this is called the interval. So this is the interval. So when I write, this is what the calculator show me. So when I write, I will write like that. I will write it like that. Okay, now. Hello? Are you okay? So how am I going to interpret this confidence interval? Yeah, so you see how I interpret. I have to go to the next one because my iPad is a bit small. Okay, so I'm going to interpret. You see how I interpret. So I will write down there. Okay, you can say you are 95% confident, but usually we'll write we are 95% confidence that the true population mean weight of bags produced by this machine can be as low as, okay, unit is very important, 999.6 gram or and go as high as 1001.8 gram. Okay, so just now we said that whether to adjust or not, correct? If it is above 1001 gram, you need to adjust. above this one or below this one. Then you need to adjust. So now based on this confidence interval, do you think it need to adjust? Okay, huh?
Yes.
So this is the weight. So I can also the mean weight, the possible mean weight. So I can also put in a number line. Lowest 999.6 gram. Highest 1001.8 gram. So this is my confidence interval. So the highest it can go is here. 1001. So how am I going to justify whether, how is he going to decide whether to adjust or not? So I will say, how will you say it? Based on the confidence interval. For this confidence interval, another one, I don't know, it may change. Based on the confidence interval, the highest possible mean weight is 1001.8, right? Which is greater than 1001 gram. So therefore, need to adjust or no need to adjust?
Adjust.
Yeah, lor. You see or not? You see? So I start from the first one. Look, this is a very simple one. When you write your folio, it has to be more complicated. Later, I will explain to. Later, I will discuss with you next year. Next week. So now, I have a situation. So I need to make a decision. How I'm going to make a decision? Okay, I'm going to use the things that I learned about sampling distribution, because it's impossible for me to weigh all the machine, all the bags produced by this machine, correct? So you have to determine the sample size. Yeah, so that is a way to do. So you get a sample. Your sample must be a random sample. So you find the sample mean. So this is a point estimator. So now I give you the whole picture. This is the point estimator. So based on the central limit theorem, so I'm trying to estimate, or I'm trying to predict an interval for my possible population mean. So I have to determine my confidence level. Yeah, so based on that confidence level, so what is the meaning of confidence level? Then I start to explain. So based on that confidence interval with my GC, then I can count the confidence interval for the true population mean. So that means I'm 95% confidence that this one will capture the population mean. Yeah. So my population mean can go as high as, mean weight can go as high as this. So this will make my decision. Yeah. Whether to adjust or not to adjust. So it depends on the scenario, depend on your claim. So this time round, I try not to give you the formula first. Okay, I will give you the formula the next lesson. So are you clear? All the things?
More or less.
Yeah. So because it can be very confusing if I start with the formula. So I prefer not to. You understand the meaning of confidence interval? Confidence interval is a prediction or an estimation, and an estimation of the true population mean. So I don't know what is the mean you are talking about, based on a sample mean at a certain confidence level. So that is the meaning of confidence interval. Are you okay? Hello,
Yep. Okay.
class? Huh? So afterward, only I tell you the formula. Actually, now you can do all the exercises already. Do you know that? Because I know last time when I tried to introduce using a formula first, correct? I tell you a lot of confusion. And when you write your folio that time, correct, I headache. So I try to change my headache this time. I don't want to follow the books. Hello?
Yes.
Okay. So very important, huh? Why we take sample? Because it's impossible for us to study the whole population. The population is too big. So when you take samples, you have to know which powerful theorem you have to go to. So your one sample mean is just as a point estimator. For it to happen is very, very unlikely. So we find a confidence interval. That means a range of value based on CLT. Okay? So then we base on a certain confidence level. Now, if I ask you, if I reduce my confidence level, will this interval wider or narrower?
Narrower.
Narrower. Good. Excellent. It will be narrower. Definitely, you have less confidence, but am I right? Okay. So why is less narrower? If I increase my sample size, will this interval be wider or narrower?
Wider.
Okay, why is wider?
95% of a bigger population is still.
No, I fix my confidence level.
To be what?
Confidence level is 95, fixed. Now I increase the sample size. Okay, this situation, n equal to 7. Then I put another one, n equal to 15. Which one will have a wider confidence interval? Which one is wider? The confidence of which one is wider? $15. Okay, why you say 15 is wider? Look, if the sample size is bigger, isn't it that sample mean will have a smaller distribution? Smaller standard deviation, correct? Still remember according to CLT? Yep. And the standard deviation? Which one have a greater variation, you tell me? Which one have a greater variation? The 15 one, the size 15 or size 7?
Size 7.
Yeah. right? Less variation means your prediction is more close to each other. Am I right? Hello? Okay, next lesson, I will give you the formula. So I hope everyone understand what is my confidence interval for mean. That means I'm going to make a prediction of the true population mean based on a sample mean and at a certain confidence level. So I'm going to use that predicted or estimated interval to justify my claim. Okay, Anna?
Yep.
Okay. So I hope I have done my part to explain as clearly as I can to you. Okay. So I will see you afterward. Then I will tell you how the formula come about. Okay? Can I not?
Yep.
Yes, Miss.
Thank you, class.
Thank you, Miss.
Mm.
Thank you, Mr.
Mm.